The purpose of this video is to give you some help with the drawing package that you're doing in regard to your design project. I'm going to give you a quick introduction, then you're going to hear from somebody with a lot of experience in doing drawing and making things. Now, this is going to be a very detailed video. He has a lot of specific suggestions for you when doing drawings, and so my suggestion is you watch a little bit at a time and make sure that you digest it, because being able to do good drawing packages is essential for you as an engineer, because what you're doing is you're creating the instructions that then a machinist or a 3D printer or somebody like that is going to take and then create your part. And so it's essential that you learn how to create those instructions in a way that effectively communicates to those people. Okay, so you see behind me, here's an example of the start of a drawing package. You'll see in the video that this is actually the last thing that you'll do. But your drawing package, the first thing is going to be an assembly drawing. Something that shows all of the parts, it shows how they go together. If you have sub-assemblies, sometimes you'll see those as sub-assemblies, and there's going to be a bill of material. Now, you're going to see more details later on about these actual components, but I just wanted you to see the big picture of what we mean when we say drawing package. So you've got this assembly piece. Sometimes, again, then there'll be this sub-assembly drawing. And then what you're going to have is, even if you don't have the sub-assembly, you'll have this assembly piece. Then you'll have the detailed 3-view drawing of each piece that has to be manufactured. And the purpose of this drawing is for the machinist or whoever to take this and make it. So that's a lot of the detail that you're going to hear in the video, is what kind of information to include. How do you dimension so that the person making it can know how to do that correctly? And so this just gives you an example of the couple of parts. I also wanted to show you an example from one of our capstone designs. So this was the full design right here. This is actually a device to proof load different slings. These are big hydraulic cylinders. And so here is their initial drawing. So this, if you want to call it, this is their assembly drawing. So it's showing their design, it's showing all the parts, and instead of numbering them, what they did is they labeled each of these pieces. So just blowing up on this a little bit, you can see these two parts right here, cam mechanism and the adjuster 42. And so for each one of those, there's going to be an assembly drawing. So right here, here's the cam mechanism. And each of the parts are labeled. They're in the bill of material here. So this is the cam. This is the lip. So if I go down one, we're going to now see a drawing for the cam. So this is the detailed drawing for the cam that would be used to manufacture it. On the next page, then here is the drawing for the lip, and it would have the same kind of thing. Also, we said there's this adjuster 42 that I had highlighted. Here's the drawing for the adjuster 42. This was actually a really complicated part. So this assembly drawing right here has the purchase parts listed, and it's got the bill of material. If we go down one with it, it now has all of the manufacturer parts listed. So again, each of these parts are numbered, and then there's going to be a drawing for each one of these. I'm just going to hone in on these two right here. So you see part 6 and 7. Down here you see, okay, we're on number 6. So you see, here's this part. Here is the drawing that would be used to manufacture that. And then you see that part number 7 right there. Now here is the drawing to actually manufacture that. Okay, so that just kind of gives you an idea. When we talk about drawing package, that's what we're talking about. You've got the assembly drawing that shows how everything goes together, and then each of the drawing that somebody would need to make that. If it's really complicated, you may have several levels of subsystems before you actually get to the 3-view drawing that someone would use to make it. Okay, so I hope this helps you. Like I said, go through it in pieces. There's a lot of detail. Pay attention, because this is great information for you to be able to create good drawings to communicate to somebody.
Well, hey there, my name is Daniel Caldwell, and I work at Tandem Lock Incorporated. I've done a lot of drawing work over the years, and kind of the assistant draftsman at Tandem Lock. But I come from a machining background, done a lot of manufacturing over the years, so I've got to know what a good drawing looks like and what things work well to convey a message to the manufacturer of how you want that part to look. So hopefully today I can share some of that experience with you guys and help you to make a good drawing package. Of course, there's a lot of rules you'll learn about drawings, a lot of formal ways to do manufacturing drawings, and they can certainly vary from company to company. And for the process that's being done to that part, whether it's 3D printing or machining or welding. So a lot of what I say today won't apply, to every job you ever do, but it's pretty good general information. So to start with, we've got this wind tunnel project that we did a couple semesters ago, and this is what we're going to kind of use to lead you guys into your drawing effort. So this was our design. It used a strain gauge and some beams that bent under the load of the drag and lift. And it was a little unique, a little different way to read the forces, but it was something we wanted to try out. So you can see it's got a lot of elements to it, and it looks maybe a little intimidating to do a drawing package for, but it's a good example to show you some of the more maybe unique things you might have to do in your drawing package to show those parts. So one of the parts that I'm going to show you guys today is one of these side plates. And so you can kind of see that separated from itself. And this is, it's certainly got a lot of, internal things going on. You notice you've got this pocket right here that does not go all the way through the part. You've got another pocket here that doesn't go all the way through the part. So those could be a little bit difficult to deal with as you look at your different drawing views. Speaking of drawing views, let's get that down first. So across the board, don't care who you're working for or where you're at, you're going to have these standard drawing views. And there's really not any exception to that rule. There's some rules that you can break. This isn't really one of them. You are not allowed to rearrange the orientation of these views. You don't always have to have all of these views, but you always, for example, you can have just a front view, or you can have just a front and a right side, or you can have just a top view, or just a top and a front, but you can never have a right side view on top of a front view. If you're going to have a front view, above it should be, or if you're going to have a front and a top, above it they should be in this orientation. You can't put a front view and then show a left side over here. It always has to follow this orientation if you're going to have all of these views. Isometric view is certainly optional, but if there's room for it, and if you can, put it in there, if your CAD software allows for it to be put in there, I would certainly recommend it. It definitely helps a lot. But this is a really big deal. And so this is kind of one thing I think that I've seen some people do, and they say, well, it fits. Because of the orientation of the part, it's a really long part. It's actually a lot easier to put, a left side view right next to a right side view. Well, that might be true, but you just can't do it. If you've got to do that, then you need to add another sheet. You can have a left side view and on a separate sheet put in a right side view, but anybody manufacturing that part is going to expect this orientation. So if you're going to have a left side and a right side, you need a front in the middle. There are some ways to work around that. We're going to show you that in the drawings. So let's look at the drawing for that plate we just looked at in CAD, in the 3D model. So this might look a little bit intimidating. Looks like, wow, there's a lot going on there. I couldn't really make a drawing like that. It looks really hard. But your CAD software should provide, like if you're using SolidWorks, for example, should provide the ability for you to do this without a whole lot of hassle. So these are what's called section views. So notice here I have a front view of my part, and right below it I have the bottom view of my part. Now, if you took a drafting class, you should kind of understand how those work, but it's basically taking that part as if it was a block and flipping it directly in your hand. Anyway, so you've got your front view here, I've got a bottom view, then I have a right view. Now, what I don't have over here is a left view, and the reason I'm able to get away with that is because this is labeled differently as a section view. So if you need to show part of your drawing or part of your part that doesn't follow that guideline, then it needs to be labeled differently as what it is. And in this case, that's a section view. So you say, well, section BB, where does that come from? Well, if you look right here, this is exactly where section BB is broken. And so again, I'm not here to really give you a CAD tutorial, but you can find on YouTube how to do that in your CAD software. How do I create a section view? It should be pretty straightforward. Section view should always have cross hatching. That's what helps you know that it's a section view. The same thing is done over here with section AA. It's cut right here. Now you might say, well, why are all those there? Well, imagine if all these things had to be laid out on this one view. That would be kind of crowded. There'd be a lot of dimensions shown on that one view. And so sometimes you create section views or alternate views, they call auxiliary views, to spread things out some so you have more places to dimension. Sometimes you create them because you need to show an internal feature. For example, this one shows the depth of that slot that was on the bottom of the part. Well, sure, I could have showed that here. But it helped to spread it out a little bit. It also shows the depth of this pocket right here. Well, you might say, well, you could have dimensioned that right here, but you're really not ever supposed to dimension to a hidden line. It's another kind of given rule that you normally won't see a manufacturing drawing do. You don't dimension to hidden lines. Hidden lines are there to show you that something is there so that you can help, kind of helps to orient you in the part, but they're not there for dimensioning to. So as a general rule of thumb, don't dimension to a hidden line. If you need to, that probably means you need an auxiliary view. So this auxiliary view was really created to allow me to get the depth of that pocket. Another way I could have done that is by labeling it, pocket such and such wide, such and such long with the depth. That's not as desirable as this, but sometimes, you have to do those things if you run out of space. So I guess we'll just move through this drawing now that we've talked about the views. Notice my isometric view is not in the top right corner. That's okay. You can put that isometric view wherever it fits. Normally you'll find it in the top right corner, but this was kind of a crowded print, so it ended up down here. You might say, well, you just delete it, and you certainly could do that. It's not a requirement. I feel like this is a part that benefits from an isometric view, so I left it there. So moving from left to right here, so let's talk about some of the details that are going on here. First of all, I thought I could drag this, but I guess not. First of all, detail lines should always have a gap between the object lines. Notice how these two lines right here don't touch the object lines. Your object lines are the lines that actually make up the part. Detail lines are the ones that your arrows are touching or that are, showing that dimension. Make sure you have a gap. That's probably a setting in your CAD software you can play with. So if you'll notice anywhere these detailed lines, on the drawing, they always have a gap. Now you say, well, this one crosses the object line. Well, it's got a gap between what it's actually dimensioning here. So that's important. Also, make sure that your detailed lines, whenever possible, are outside of the part. Notice how this one is inside. Whenever possible, you want to make sure that your numbers and your lines are off of the part itself so that you don't want to have things dimensioned inside of your part, if at all possible. Sometimes you can't avoid it, but whenever possible, bring those things off the part and outside of the part. Let's see. Again, we have our object lines or our section lines. If you're going to do a section view, it has to be labeled, and you have to have the line on the drawing it came off of showing. Also, that section view has to line up with where that section was. I could not put the section view, or I should not put the section view down here. It needs to be in line with the section that was cut. That's probably not a hard rule, but I've never seen it done any other way. Radiuses can be dimensioned pretty easily with just an R and the size of the dimension. You don't have to write the whole word radius. Another thing worth noting is if you have radii on a part and you've got a lot of them and they're all the same, you can just say so. You can say typical. You can say, if let's say there was a lot of radii on this part that were 100 thousandths of an inch. Well, I don't need to point to every one of them. I could count them and say typical 41 places, or I could just say typical, and that's enough. Holes. If it's a through hole, make sure you put through. That takes all the guessing out. You might say, oh, well, there's no hidden line, so it's obviously through. Well, that's fine, but put through hole if it's a through hole. Just don't make anybody guess and stare at the drawing. If it's not a through hole, in this case, it's a good idea to show how deep it is. This is a symbol for depth of a counter bore. So that's a 400 thousandths diameter hole. This symbol means diameter. Oh, that's another thing. Always use the diameter symbol on a hole because that tells me that you're talking about the diameter. Now you could have lines inside here, 2 arrows that show that you're talking about that diameter, but this is a cleaner way of pointing at that hole. Another rule that comes to mind as we're going through this is all of your holes that are drilled should have center lines. Now I know that might feel like you're cluttering up your drawing, and boy, it sure looks a lot cleaner without them, but you got to have the center lines because it shows me that it's a hole. It seems a little silly sometimes. I don't always like it myself, but it's just kind of a rule. So make sure your center lines like these are a plus shape with a break in them, and then other lines that extend out past the whole diameter itself. There's a lot of different formats for doing center lines, and they're all slightly different. Sometimes these lines are dashed, but you got to make sure that this is broken. So if you have to change the scale of your center lines or something, there needs to be a break here, and they need to extend out just past the diameter of the hole being drilled. It's also a good idea to use center lines when it deals with part symmetry, and we'll get into that later, because it can actually save you a lot of hassle and things that in making dimensions. So we'll show that on another part. Again, everything on that view doesn't have to be dimensioned on that view. If I would have dimensioned the width of this slot and the height of this slot and the size of this rectangle and all these different things on this one view, would be really cluttered. So take advantage of the fact that you have all of these drawing views at your disposal. And while you may not always need to use them, you certainly can. One kind of little rule though is generally you don't have a drawing view if you're not putting dimensions on it. So if you have all 4 of these on your drawing, but you only actually put dimensions on 3 of them, you should probably just get rid of the other 2. Sometimes you might feel like one of those actually really helps because it shows some information about the part, even though you didn't put a dimension on that. Then it's probably okay to keep it. But in general, if you didn't put any lines on there, any dimension lines, then they shouldn't be there. Get back to where we were. So this is your right side view. Notice there's no well, there are a couple dimensions on here, but I didn't do a lot on this view. There's really not a lot that would be done on this view. Maybe I could have dimensioned the overall width, but I decided to do that down here instead. Totally up to you where you put those dimensions, whether it was here, that 1 inch width, or whether it was down here, doesn't matter. Whatever is, looks the best on your print as far as, keeping it clean and not too cluttered. I did choose to dimension the radii up here. Again, it's just the radius and what its dimension is. You don't have to write the whole word radius or anything like that. Also, I would note that you probably should not label your units on every dimension, and you probably shouldn't put a tolerance on every dimension. You would have a title block down here that would say things like all dimensions are in inches. And then maybe you'd have a tolerance block. And this is a good example of a tolerance block. All dimension inches and tolerances are, and they're denoted by number of decimal places. So 2 decimal places has this tolerance, 3 decimal places has this tolerance, 4 decimal places. And a lot of times that works really well. If you need, and so I would recommend using a tolerance block like that. If you need to be more specific with a dimension, then put a tolerance on that dimension. But don't tolerance every single dimension on your print. Maybe you need something that's not a bilateral tolerance like that, plus or minus. You need something that's, minus nothing plus something. Then certainly put that on that dimension, but avoid tolerancing every single dimension independently on the drawing. And avoid using units for every single, your whole drawing should either be in inches or millimeters. Unless, and if there is some special reason, then do it independently for that one item. So we'll move on to the next, the section AA here. Again, that's clearly referenced here. Also note these arrows for your section views. They're pointing in the direction that the cut was made. What that means is that I'm looking in the direction of those arrows. And so if I were looking the other way, I would see the back side of this pocket right here. But notice how I don't see the back side of this pocket. I see all the way through. It's clear. That's because I'm looking in the direction of those arrows. So generally, you would choose that arrow direction in whatever, makes the cleanest print for you. Whatever, if you didn't need to see the back of that, then don't. Just kind of play with it and try both things and see which one works best for your particular case. Anytime you have dimensions that are going to be stacked on top of each other, you want the wider dimension outside. Obviously, you want to avoid crossing over your detail lines with each other. So I wouldn't want this 0.473 on top of the 1.988 because that would be really cluttered. So put the narrower dimensions or smaller dimensions inside or underneath your taller dimensions. It's also a really good idea to think about where your datum point is going to be on your part when you're manufacturing this thing. So say you were going to put this in a CNC machine, or maybe you're just going to measure it after it's 3D printed, you're going to want a single point of reference usually on a part. Whenever possible, that's what you're going to want. If it's a CNC machine or any kind of machining operation, you're going to want to set this up and you're going to want to have a part local coordinate system. And so that's going to come from usually a single place on that part. That's certainly preferred. And so what you'll find on these drawings is that everything comes from this bottom right corner. In one way or another, it's referenced off that bottom right. So all these dimensions are pulled from the bottom of the part. All the dimensions are pulled from the right corner of the part. And that's just going to come in handy when you start measuring things, because you're not going to want to measure off of a point over here, really. It's going to be a little harder to, find out where this hole is if it's coming off of this angled surface. But if I'm trying to measure and check my part and it's coming off of a flatter surface, that's going to be a little easier to measure. Now, of course, this one starts to taper to a radius, so that's a little bit of a moot point. But in general, pull all your dimensions from one place, or at least try to. And also think about what matters to you as the designer. Do you really care? If you, for example, I dimension this hole to this hole and then this hole to this hole with this 1.52 and this 0.848. Well, maybe it was really important to me that this hole be the exact dimension from the bottom of the part. Maybe that was really critical. Well, then that's what I should dimension, because if you think about it, with a 3-place decimal, I've told the manufacturer that with a 3-place decimal, they have a 5/1000th of an inch tolerance. Well, tolerance stacking would allow this hole to actually be about 15 thousandths too high or too low. Now, if that's okay, then fine, leave it that way. It's going to have a location between these two holes of within 5 thousandths, between these two holes within 5 thousandths. Maybe that mattered more to me. What you don't want to do is do both. Don't do this and then also dimension from this hole to the floor, because now you've not only have you dimensioned the part twice, but you've sort of contradicted. So if this hole's location to the floor matters a lot, then dimension it so, and take away this 848 dimension so that you're only dimensioning that hole's location once. Don't do both, because then you're going to end up with confusion, and the operator's going to say, or the manufacturer's going to say, well, you told me I had 5 thousandths here, but then you said I had 15 thousandths in another way. So only dimension things once. Let's see, some other things so when you're dimensioning a hole's location, always grab off of the center line. Don't come down here and measure off of anything else. Your dimension lines for a hole should always come off of a center line. Now it becomes a little hard to see that because this is cross-hatched, but you can see that there's a gap there, and that is actually pulled from that center line. Same thing here with the 848. It's pulled from your center line. It's part of the reason why your whole center line should extend outside of the hole, so that you can grab them for dimensions. So moving down here to the bottom view, hidden lines need to be on a drawing because they help provide reference for whether this is a through pocket. Well, clearly this is not a through pocket because the hidden lines show that it's not a through pocket. Also, this section view does a great job of that. But let's say you didn't have a section view. All you have is your front view and your right view. Well, then you'd have no real way of knowing except that it shows in the hidden lines. Same thing with this pocket down here. It shows that it doesn't go all the way through. It shows that this hole doesn't go all the way through. Well, if you've shown all that you need to show with your hidden lines, and then you have a view that just looks really cluttered with all of its hidden lines, and they're really not serving a purpose anymore, it is okay to remove them, but you have to say so that the manufacturer knows, oh, well, I don't see hidden lines because they took them out, not because they're not there. So in this view, I've pretty much already shown everything I need to show. I don't really want the clutter of hidden lines, so I put this note here that says hidden lines removed from bottom view for clarity. Sometimes you might say some hidden lines removed for clarity. Let's say you've got maybe it's a hole with an angled taper going into it and a radius on the back side, and you really just want to dimension the diameter of that hole. And if you left all the hidden lines, there'd be like 5 or 6 circles surrounding that hole. And so you might remove those. Well, you'll say hidden lines, some hidden lines removed for clarity. Perfectly fine, just make sure you say so. And if you're going to remove them, make sure you showed the information that those hidden lines would have given in some other way. Chamfers. So instead of coming in and dimensioning an angle like I did here, it's a good idea if it's just a chamfer or a corner break or maybe a well bevel to just say that it's by 45 degrees or by 60 degrees. Actually, let me rephrase that. That rule really only applies to 45 degrees. If it's anything but 45 degrees, you're going to have to dimension the side and the, because you don't know they're not equal legs. So you'll have to dimension a little bit more than this. But this is a good shortcut if it's just a 45 degree. That works for maybe a bevel and a hole, or, like I said, a well bevel or something. If it's 45 degrees, you can just say it just like this. Notice I only pointed to one of them. I didn't point to both sides, but I said typical. Typical basically tells the manufacturer that if it looks like this, then it's the same. Now, what I could have said was 2 places, but I didn't, and you don't have to. It might have been better to say that so that they're not looking all over the part to see if there's another one. Well, I see 2 right here, but was there a third one somewhere that I've missed? So saying how many is probably a good practice, but it certainly can clean up your drawing if you use that little typical abbreviation. And I think that's about it for this. Let's move on to another drawing here. Oh, also, it's a good idea to have some notes on your drawing. You're going to have your part number, a part description, tell them what kind of material to make it out of. In this ref right here, so you could have a bill of materials on your drawing. You could tell them an awful lot on your drawing. Actually, you could tell them, the material supplier. You could tell them all kinds of things. And in the case of tandem lock, where I work, notice the tandem lock on this drawing, but we use a bill of materials separately, and that would give all that information. And we use different software for our bill of materials. It's not in our CAD software. So ref just means reference something else. There's information about that, but it's not going to be found on this print. Sometimes you might say that about a dimension. You might see a reference dimension, and that just means that, well, machinists like to think that means it's not important. But that's not the case at all. A reference dimension means that it comes from somewhere else, and you really should have that information with you when you're making this part. Finish, whether it's painted, whether it's sandblasted, whether it's zinc plated, in this case, it was going to be printed out of plastic and stay the same color. And then a calculated weight is a really good thing to have. That's going to depend on who you're doing the drawing for, but it's a good, reference, especially, if maybe you're doing this in a facility where somebody's going to have to take this thing off of a machine and move it somewhere else. We do things at Tandem Lock that can weigh thousands of pounds. Well, if I'm, the guy's got to go get a strap or a chain to hook to the crane, or he's going to use a forklift. All those things have capacities and working loads, so it's good to know what he's picking up, what it weighs. And so, sometimes you might have the calculated weight after machining and before. In any case, those are good things to have. I guess we can come down here and talk about the title block a little bit. If I can get zoomed into it. We mentioned the tolerance block. By the way, title blocks are a gotta have, not an option. How you format the title block is definitely optional, and it's usually already decided by the company you're going to work for or whoever you're doing work for. For your project, it's a good idea to have some basic things on there. A tolerance block, approvals, who drew it. You want to know who to go back to talk to if there's a question about the drawing, or maybe a dimension that you can't tell where it's, whether it's dimension to the inside of the gap or outside. A date. A lot of times you're going to have an engineer approval, or, the draftsman isn't necessarily the person that designed it. So you'll have maybe multiple approval blocks and then their initials there. Scale. It's a good idea to say whether it's not to scale or if it is to scale, what that scale is. And, if you don't know, just say not to scale or do not scale this drawing. Basically, that means that if maybe you didn't dimension something. Like, for example, I don't have a dimension for this edge right here. But if I say this drawing is to scale, 5 to 1 or something like that, then the machinist or the operator, whoever's manufacturing this, can go here with a pair of calipers and measure this line and scale it up by 5 and say, oh, well, that's what this dimension should be. That's why it's kind of dangerous to say things are to scale, because you don't know how it got printed out. And so as a general rule of thumb, unless you really need to, just say do not scale this drawing or not to scale, even if it is to some scale, because you're basically saying you can measure things on this drawing and rely on them for dimensional information. Ignore the cage code. I have no idea what that is. Drawing number. Tandem lock, we like to restate our part numbers 3 different times on the drawing. Not sure why, but that's not necessary. This is sheet and how many sheets there are, because let's say you didn't want to do all these auxiliary views. Let's say you just wanted to do 5 front views. You can certainly do that and have 5 sheets. In this case, I didn't want to put all these dimensions on this front view, so I created an auxiliary view and, kind of gave myself more space to make those dimensions. Didn't have to do that. I could have certainly had this front view, all 3 of these views, reproduced again on a second sheet and just done some more dimensions there. If you do that, if you have more than 1 sheet for a drawing, you have to have it down here. And even if you don't, you still need to say that this is all the information about this part, and you're not looking for another sheet, and you need to say sheet 1 of 1. If it's going to be 2, sheet 1 of 2. If it's going to be 3, and such and such. So that's a pretty important thing to have on your drawing. Let people know how many pieces of paper are they looking for to have all the information. Another thing, revision block. Not really going to apply to your project, but it's good information to know. There's been no revision, so this revision block is not filled out. But let's say there was a change, you would put revision A. You tell what was and what now is. So you might say 836 was 826, and the date that the revision was done and approval. And that lets people know maybe there's a program like to 3D print this, and somebody's going to make it again, and they're just going to use the 3D print program from 2012. And then they're going to get the drawing and they're say, oh, there was a revision done in 2014. Well, that program from 2012 probably isn't any good anymore. And so they're going to know that they have to go revise that. There's no revision on the drawing. You make a change and don't put it in the revision block, there's a good chance that nobody's going to notice that change until the part's already made. And they're like, wait a minute, I had the same 3D print, file, and it made a bad part, but it was good last time. And then you got a bunch of people wasting time trying to figure out what went wrong. So revision block is really important. Probably not so much for your project. I think the only thing we didn't talk about here was this angle. And so you could dimension angles in a variety of ways. It's a good idea to try to dimension angles in the included as an included angle. And so basically, I could have come out here and made a dashed line out to the floor and dimensioned the larger angle here, right? But that isn't really as clean. And if you think about it, it's probably not as easy to measure. And so a lot of times what you're thinking about when you're dimensioning something is, how is somebody going to measure this? Um, and so, you're going to put an angle finder up somewhere. And in this case, I know that this would be 90 degrees if I use an angle finder. So it'd be really easy for me to say, well, when I put an angle finder here, this should now be 80 degrees. Now, would you want to come in here and dimension 80 degrees? Well, no, because that's inside your part and it's going to look really cluttered and it's going to cover up some things. So try to think about, when you're doing angles, what is the cleanest way to put that information on the print, while also thinking about how somebody's going to measure it. Draftsmen are famous for putting radii and dimensioning them to a point out in outer space, knowing darn good and well that nobody can measure from that. So if that's what you have to do, it's what you have to do. But anytime you can make a drawing that saves time in manufacturing because you put things on there that are actually measurable, that's a good thing to do. Now, one thing that a lot of machinists wish draftsmen would do is dimension edge of hole to edge of hole, because that's what they actually get to measure. Well, that you can't actually do. That's not really something you want to do, because hole diameters have tolerances and hole positions have tolerance. So that's sort of an exception to the rule of making it easier on the guy making the part, or girl.